Hey guys, Mr. Freeland here. Just do a quick lesson on greatest common factor and how it applies to distributive property and groups. So here's I've got three examples I want to share with you real quick. The question here is use the greatest common factor and the distributive property to express the sum as the product. Now, what you want to do is you want to find the greatest common factor of both 18 and 27. Let's see if I can use a different color here instead of brown that I've got here. Blue sounded like a good color. Alright, so we're going to do 18 and 27. We're going to do basically the listing method of all the factors of 18 and 27. So what you want to do is you want to list them all. Start with 1 and 18. Okay? Those are kind of our bookends, if you will. And those are our limits. And so the next number is going to be greater than 1 and less than 18. Okay. So 2, let's go to 2. So 2 times something equals 18. It should be 9. 2 times 9. And you're going to put 9 right here. Because there's not going to be another number between 9 and 18 as a factor. We're going to go lower from here, and we're going to go a little bit higher from the 2. The next one will be 3. 3 times 6 equals 18. And those are all the factors, because 4 can't go to 18, 5 can't go to 18, and that's it. So 1, 2, 3, 6, 9, 18 are factors of 18. And same thing with 27. So we're going to list them all. So 1 times 27 is 27. 2 can't go to 27, but 3 can. 3 times 9. And there's nothing else. 4 can't go to 27, 5, 6, 7, 8, 9. They cannot go to 27. So that's it. So if you look at both lists, you can see right away that there's several common factors. Of course, 1 is always going to be a common factor. Okay? 3 is also a common factor. And 9 is also a common factor. But the greatest of all 3 is this one. So this is the greatest common factor. Now, how does that help here in this problem with 18 plus 27? What it says to express this sum, this is a sum. The sum is the answer to an addition product as a product. So what's that mean is that's distributive property. So distributive property, if you go back to distributive property is basically, let's see if I can do it this way. So like AB plus AC. So AB plus AC basically means A times B plus C. So what happens is A is being multiplied to B to get AB, and A is being multiplied by C, or 2C, to make AC. Alright, so what happens here in this situation is what we're going to do is we're going to divide both 18 and 27 by 9. We're going to pull it out. Okay, so if you divide 9 out of 18, you would get 2. Let me see if I can go back to blue here. So if I pull out the 9 out of the 18, I get 2 left over right here. And if I pull out the 9 out of 27, that's a 3. And I'm going to put 9 in front of parentheses. So basically it's 9 times 2 plus 9 times 3. Or in this case, we can add them together, which will be 5. 5 times 9 is 45. And that's what these two equal. If you add those together, that would equal 45. So that's basically what they want you to do here, is basically just set it up as a distributive property. So hopefully that helps using the greatest common factor. You're just pulling out the greatest common factor out of both numbers, and it expresses as a sum as a product. Product means the answer to a multiplication problem. So hopefully that helps. Number 2, you've got a word problem here. It says that there's 24 6th graders and 40 7th graders. Mr. Freeland wants to divide both grades into groups of equal size. Okay, so like I would want every group to be 5 people each. Okay, well, what we're going to do here is we're going to find the greatest common factor, kind of what we did up here. And what we're going to do is we're going to take the greatest common factor, and we're going to divide both into 24 and 40 to find out what's the biggest size group that we can have that's going to be in each group across the board for both grades. Okay, but we can't add them. You can't add them together and go, okay, 64 students, and then put them in groups. The 6th graders have to stay amongst themselves, and the 7th graders have to stay amongst themselves. Alright, so what we're going to do is we're going to find the greatest common factor of 24 and 40. Alright, so you have to think, okay, what's the biggest and smallest number that can go into 24? Well, it's 1 and 24. And then what is the next biggest number? Well, or I should say the next smallest number. 2. 2 can go into 24 2 times. And then we can do 3 and 8, 4 and 6, and I believe that's it. 5 can't go into 24, and so those are all your factors of 24. You're going to do the same thing with 40. So 1 and 40. 2 goes into 40 20 times, so it's going to be 2 and 20. So we're going to go a little bit higher here, a little bit lower here. 3 can't go into it, but 4 can. 4 times 10. And then 5 can go into 45 times, 8 times, and that's it. 6 can't go into it, 7 can't go into it, that's it. So if we look for common factors, we've got a lot. Again, we're just looking for the greatest common factor, and you might be able to see it right off the bat, but we've got 1, 2, 4, 8, and there's nothing else. So the greatest common factor is going to be 8. So that means we're going to divide 8 into 24, 8 into 40. So when we divide 8 into 24, we can get 3 groups of 6th graders, where each of the groups have 8 students. Okay. And then for the 7th graders, you can divide that by 8 as well. You're going to get 5 groups. So 5 groups of 7th graders. Each group having 8 students each. Okay? So that's what you're going to be looking at right here. Alright, so we're going to do another problem very similar to this, except it's going to be talking about baseball cards and football cards. Alright, so Alan's packaging 21 baseball cards and 12 football cards to sell at a swap meet. Each packet will have to have the same number of cards, okay? And each pack will have cards for only one sport. So you can't mix, baseball cards with football cards. They can't be mixed at all. It's either 2 baseball cards each group, 3 baseball cards each group, 4, whatever the grouping is, it's all going to be baseball cards, and likewise with football cards. Alright, so what is the greatest number of cards he can place in each packet? So you got to find the greatest common number, factor for 21 and 12. Because he wants to have the same number of cards for both sets of cards. Okay, obviously one's going to have more groups than the other. 21 will definitely have more groups because it's a bigger number. But so you're gonna look for greatest common factor between 21 and 12. And if you do that, you'll see pretty quickly what it's going to be. And it's not going to take too long to do this, hopefully. I'm just going kind of fast here, just so, because of time, I don't want this video to be too long. But anyways, you can see it's 3. So 3 is the greatest common factor. It's the biggest number that can go into 21 and 12 at the same time. So if you divide 21 by 3, you get 7 groups of 3 baseball cards each. Okay. And then 3 also goes in 12 4 times. So you're going to have 4 groups of 3 football cards. Okay, and so that's basically it. So the greatest number of cards he can place in each packet is 3. And how many packets will be there for each sport? Well, it'll be that right here. It's 7 and 4. So I guess instead of packets, I should say groups. I should say packets. So I apologize for that. Alright, so it's packets. 7 packets of 3 baseball cards each, and then 4 packets of 3 football cards each. So that's how the greatest common factor helps you determine the group size. In this case, the packet size. Now here at the bottom, this is piggybacking off of this problem here. What if Alan decided to keep 1 baseball card to himself, right, and just sell the rest? So instead of having 21, he has 20 to sell, and he has 12 football cards to sell. So 20 baseball cards and 12 football cards. So how would that change? Well, it would change quite a bit, right, because the greatest common factor of both of those numbers are going to change because it's a different number. You've only got one, and it's a slight change, but it still can make a huge difference. So if we look for greatest common factor, we'll see quickly here that it's going to be 4. 4 is going to be the greatest common factor if it's 20 and 12. And so when you divide this by 4, you'll get 5 packets, right, of 4 cards each when it comes to baseball cards. And then 4 goes in 12 3 times, so you'll have 3 packets of 4 cards each when it comes to football cards. Okay, so that is definitely different, right? Because before you had 7 packets and 4 packets. Now, because of that 1 card, it's going to be 5 packets and 3 packets. So he'll have 8 packets to sell, whereas here he would have 11 packets to sell, just because of that 1 card. Now, granted, there's more cards here to sell, and there's less cards here, but he could probably make more money if he had just sold that extra card they wanted to keep. So, anyways, decisions for him to make, obviously. Hopefully this helped. Let me know if you need more examples. I'd be happy to share it with you. Just let me know via email or in person, and I will send that to you all. God bless. Have a great day, and I'll catch you in the next video. Bye-bye.